Hello everybody, this lesson is going to go over how to name ionic and covalent compounds. One thing I want you to really understand from the beginning is that naming substances takes a lot of practice. There are a lot of unique combinations of atoms and names and things like that that require you to do some practice so that you're exposed to some of the patterns. I'm going to go over all the general rules. And then the biggest thing that we have to do is practice, practice, practice. It's going to really require that you know your ions, okay? So that's something I want you to work on is memorizing your common ions, both the names and the formulas. That's the only way we're going to be able to do this. All right, so let's get started. Just some basic, right? Chemical formulas is a shorthand that we can use. It tells us the name of a compound, what type of atoms are in the compound, how many of each element there are. It gives us a lot of information. When we look at that formula, we're going to be able to get a lot of things out of it. The way you read a formula is that you're going to have symbols for the elements, and you're going to have subscripts, little numbers down below that tell you how many of each element there are. So for example, C8H18. There are 8 carbons and there are 18 hydrogens. The little subscript applies to the element that came before it. So there are 8 carbons and 18 hydrogens. NH4, there's 1 nitrogen and there are 4 hydrogens. If there's no subscript, like you see after the nitrogen, there's no subscript here. That means there's a 1. Just like in math class, you don't usually write 1x. You don't have to put the 1 there. We just say NH4. We don't say N1H4. Sometimes you may see parentheses. So for example, in this compound, Al2, parentheses, SO4, close parentheses, and then a little subscript of a 3. When you have parentheses like this, what you have to do is you have to distribute, kind of like in math class. We look at the end of the parentheses, and this is telling me that I have 3 of these SO4 packages, okay? So I have 2 aluminums. The aluminum is not inside the parentheses, so I do not distribute this 3 to it. It already has its own subscript, okay? I have to distribute the 3 to the sulfur, and I have to distribute the 3 to the oxygen. So I end up with 2 aluminums, I have 3 sulfurs, and I have 12 oxygens. And that makes sense because each of these SO4 packages came with 1 sulfur and 4 oxygens, and I have 3 of these packages. Okay. So I'm going to give you a minute. If you need more time, pause the video. See if you can figure out how many of each element you have in those formulas. So for the first one up here, there's 1 calcium. There's no subscript here, so it's just a 1. And I have 2 bromines. Down here, I have parentheses, so I have to be careful. The copper is not inside the parentheses. There's just 1 copper. I have 2 of these packages here, so I'm going to distribute, so I have 2 nitrogens, and instead of 3 oxygens, I have 6. So now you know how to look at a formula and figure out which elements there are, how many you have of each, and how to deal with the parentheses. The next part, in order to decide how to name something, you first have to know whether or not it's ionic or covalent. Now remember, if it's ionic, you have a cation and an anion, a plus being electrostatically attracted to a minus. Usually that means a metal and a nonmetal, but not always. If it's nonmetal and nonmetal, covalent. So if we look at this first example, while nitrogen is a nonmetal, and oxygen is a nonmetal, so that must be covalent. Potassium is a metal, chlorine is a nonmetal, so that must be ionic. You try the next three. I'll give you a moment. You can pause the video if you think you might need some extra time. All right, iron is a metal, oxygen is a nonmetal, so that is ionic. Carbon is a nonmetal, and hydrogen is a nonmetal. You have to be careful. Yes, hydrogen is on the left side of the periodic table. Yes, hydrogen is in the alkali metal column, but if you look at your color coding for the classes of elements that we did in an earlier set of notes, you will notice hydrogen is colored as a non-metal, right? You have to be very careful with that. So this is a non-metal and a non-metal. It is covalent. This last one always messes people up because they say, oh look, non-metal, 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 non-metal. It must be covalent. But they are forgetting that they have common ions that they have to recognize. NH4 is actually NH4 plus 1. This is an ion, right? NH4 plus 1. That's called ammonium, right? On our common ion sheet. CO3 is actually an ion as well. It's CO3 2 minus. Okay? This is carbonate ion. This is ionic. We say it's polyatomic when you have these complex ions, and if you don't recognize them, you are not going to know that that is an ionic bond. I have a cation and an anion. It's very, very important that you start to memorize those common ions. The reason we have to identify if it's ionic or covalent is because they have different rules for how we name them. We're going to do ionic first, and then we'll do covalent. When you name ionic compounds, there are two types of compounds. There's binary and polyatomic. Binary means there's only two types of elements. Sodium chloride, magnesium fluoride are a couple examples. Yes, this has 3 atoms, but there's only 2 types of elements. I have magnesium and I have fluorine, right? Polyatomic is that there's more than 2 types. You can see some examples down there. When we name binary compounds, you put the cation first and then the anion. That's basically the same as metal and nonmetal. You ignore the subscripts. You do not have to tell people what your subscripts are. They can figure it out themselves. That's something that's kind of nice. You don't have to tell them. Remember that the D block, the center of the periodic table, is called transition metals. Transition metals can make lots of different charges. You have to tell people what charge, and you have to use Roman numerals to do it. So for example, Mn Roman numeral 4 is manganese plus 4. This is a manganese ion that has a +4 charge. They will always be positive, right? They're metals, they're cations, and you tell people what the charge is. The cation is going to keep the same name as the periodic table has. Potassium, sodium, iron, gold, zinc, right? They're going to just keep the same name. The anion part's a little different though. We have to change the ending so that people know that it was an ion, okay? We just change it a little bit. We're going to drop the end and say "ide." So this, we should all probably know, is sodium chloride. We don't say sodium chlorine. We change it to say sodium chloride. You'll get a hang for where to drop the ending. They all have a similar sound. So for example, fluoride, chloride, bromide, iodide, oxide, sulfide, selenide, nitride, phosphide, right? You can kind of hear a little bit of a pattern there. So this first one is silver chloride, not chlorine, chloride. You try the next two. This is magnesium, and it's not oxygen, it's oxide. Magnesium oxide. The last one, potassium. It's not sulfur, it's potassium sulfide. So now let's look at naming the polyatomic ones. You're still putting the cation and the anion in that order. The nice thing is, if they have those fancy names from your ion sheet for these polyatomics, you just get to keep the fancy name. Some of them will already be "ide", some of them are not. But no matter what, you just leave their fancy names the way they are. So if you don't memorize those fancy names, you're not going to know them. This is not magnesium oxygen hydride, okay? OH is this fancy ion. It's polyatomic. It's called hydroxide. So this is magnesium hydroxide. This one down here, this is a polyatomic from your ion sheet with a fancy name. And this is a polyatomic ion from your ion sheet with a fancy name. This is ammonium, and this one is called nitrate. So they leave their fancy names alone, and we just call it ammonium nitrate. It's easy because you leave it alone. It's hard because if you don't memorize those names, you won't know what to call it. This one's a little tricky because manganese is a transition metal. I can't just say manganese fluoride. I have to tell people which type of manganese this is. That will take a little bit of practice because you have to kind of work backwards and puzzle through it. We know that fluorine is a -1 charge. It always is. It's in that column. It's always a -1. If I have 4 of them, all together this is a -4. In order to balance out that -4, manganese has to be a +4. So this is manganese 4 fluoride. If there were 3 fluorines, then I would need this to be manganese 3. If there were 5, manganese 5, etc. People always ask how many Roman numerals do you need to know? If you know up to 5, you're fine. If you don't know your Roman numerals, just, ask me. I'm happy to show you. The next one, this is polyatomic. This is potassium, and this is from your ion sheet. This is a fancy name. Cyanide. Potassium cyanide. All right, next, naming covalent. Just like ionic, we follow the same kinds of rules, but we just have to stick some prefixes in once in a while. You need to know your prefixes 1 through 10. There's a glue-in for the notes that has the list of the 10 prefixes. If you ever need larger than that, you can just look it up online or ask me, but we usually only go to 10. You need a prefix for every element. Unless the first element is a 1, then you don't have to say mono for it. We never start a compound with mono. You can use mono prefix later in the molecule, but never at the beginning of the name. So this first one, it's not monocarbon, it's just carbon. The prefix for 4 is tetra, and I don't say fluorine, I say fluoride. So this is carbon tetrafluoride. I don't say mono, I just say carbon. Carbon di, not oxygen, ide. Carbon dioxide. Now careful with this one. This doesn't have 1 to begin with. This has a 2. There are 2 nitrogens here. So I'm going to say di-nitrogen, tetra, not hydrogen. I have to change the ending. The end always changes to ide. Di-nitrogen, tetrahydride. You try the last 2. All right, 2 nitrogens and 3 oxygens. So it's dinitrogen trioxide. The last one, dinitrogen monophosphide. Remember, you can use mono later in the molecule, you just can't start with it. And it's not phosphorus, it's phosphide. There is one weird thing with the covalent names, and that has to do with double vowels. Do you see here how we ended up with the prefix and then the actual element name? When they bump into each other, there's a double vowel here. Some double vowels we leave, some we're going to fix. If you ever have an A and an O bump into each other, or 2 O's, you just drop one of them. We don't say decaoxide, we say decoxide. We don't say monooxide, we say monoxide. If you've ever heard carbon monoxide, okay? We don't say pentaoxide, we say pentoxide. Somebody decided they sounded better that way. And whoever that person was apparently won the argument because that's now the rule, okay? If there's ever an I in the double vowel, you just leave it alone. We say hexaiodide. We say diiodide. Dioxide. Trioxide. We leave the ones with I. Whoever decided thought that these sounded better leaving the I's as a double vowel there. All right, so that's it for the notes part, and then it's just going to be a bunch of practice together, kind of, for a while till we get good at this. All right, I hope that was helpful. Bye, everybody.